Hello, Legacy Sabers, Marsh here. So today we're going to talk about series and summation notation basics. So this is the second half of the basics. We talked about sequences last time, so now we're going to talk about series. Now, you're probably thinking, Marsh, what's the difference? Is there a difference? Please tell me there's not much of a difference. Well, a series is just a result of an expression when the terms of a sequence are added together. These can be finite or they can be infinite, which means that a series ends at a particular point, or infinite meaning it goes forever. Just basically a series is a sequence when we add stuff together. To add things together, we call this summation notation, also called sigma notation. So I could write the series 2 plus 4 plus 6 plus 8 plus 10 as the following. Now notice how this right here is just the sequence that generated these terms. So the 5 is the upper limit. This is how many terms are we going to do in the series. So there was 1, 2, 3, 4, 5 terms. That's how many terms we're going to use. The 2n is the rule. That's the stuff that you were finding last time to find the sequence rule. And then the bottom is the index that we're starting at and the lower limit. So starting index is right here. Okay. Now, this notation, kind of looking weird, the little e, that's actually sigma. That's what the e is. The sum from n equals 1 to 5 of 2n. That is how I would read this notation, okay? So sometimes it's just looking at math and knowing how to read it. But the sum from n equals 1 to 5 of 2n is how I'd read that. Let's practice. So I'm going to write this series in summation notation. So I'm starting at 4, 8, 12, dot, 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 going up to 100. So first thing I need to find is, well, I need to find the sequence, right? I need to find the rule. So looks like we're not adding a constant amount each time. Well, again, I'm going to do my little table work here. We got 1, 2, 3. I don't know what the 100 is. I get a 4, an 8, 12. I'm just multiplying by 4 each time, aren't I? 2 times 4 is 8. All right. So my rule is 4n. So I'm going to write my sigma. I know it's kind of hard. It's kind of like an E, kind of a weird E. I'm starting at n equals 1, right? And I'm going to go, my rule is 4n. I don't know my upper limit. So how did I get 100? Well, 4n, how can that be equal to 100, right? What number did I plug in for n? 25, right? So 25 would be my upper limit. So the sum of n equals 1 to 25 of 4n is my answer. Let's try another one. So I got another series in summation notation. If there's not anything up here, you know that's starting at 1. So, well, 4, that's not multiplying by a constant amount. We're not adding a constant amount. Oh, gross. Marsh might need to think really hard on this one. 1, 2, 3, 2, an 8, and 18. How are we getting that? We're not multiplying by a constant amount, so it's not exponential. We're not adding, it's not linear, so it's got to be something else. Well, 2 cubed is 8, but that doesn't work for 3 cubed. It's not 2 times. What about squareds? 2 squared is 4. 3 squared is 9. Times 2 would be 18. 2 squared times 2. 2 squared, 4 times 2 is 8. Oh, I bet that's it. I bet it's 2n squared. That looks like it. So let's write our series. Let's write our summation notation here. So my rule we have found is 2n squared. We're starting at n equals 1. Now I need to know my upper limit. When are we stopping? What's the last number we're going to plug into this rule? Well, I need to know, when is 2n squared equal to 200, right? Well, n squared equals 100, which would be 10. So my last number, my upper limit, is 10. So that would be my series notation in summation, or my series in summation notation. Let's try another one here. So, got quite a few things happening here. So 1 is 4 halves. That's a strange, that's just 2. 2 is 7/3. Okay. 3 is 12 fourths. And 4 is 19 fifths. All right. Well, we're definitely just n plus 1 on the bottom, right? Well, what's happening up there? We are going up by, well, it's 3. That's not a constant amount. So it's not linear. Are we multiplying by a constant amount? 7/4. No, it doesn't look like it. So it's got to be something different. Probably maybe a squared in there. How could 2 become 7? 2 squared is 4. I'd have to add 3. 1 squared is 1 plus 3 is 4. Okay. 3 squared, 9. Plus 4 is not 12. Almost. So close. Oh, but I was adding 3, wasn't I? So I was going n squared plus 3. Is that what I was thinking? 2 squared is 4 plus 3 is 7. Okay. 9. Oh. Got it. It's always good when you find the sequence. I'm not going to lie, guys. I'm actually doing this completely off the cuff. So I don't know these answers. This is me literally guessing things. So n squared plus 3 divided by n plus 1. That is the rule. I'm starting at n equals 1. I need to know the top. So 52/8. Well, it's definitely 7, right? Because n plus 1 is 7. So I'm going up for an upper limit of 7. Now, let's find the sum of the series. This is the easier side of today because literally, guys, guess what this is? You're plugging numbers in. So I'm starting my sum. My series is starting at 5. That's my lower limit. And I'm going up to 10. So I'm going to just write it out. I got 5 squared plus 1. Well, that's 26. Then I got to go 6 squared plus 1. That's 37. And then 7 squared plus 1, that's 50. And then 8 squared plus 1, that's 65. And then 9 squared plus 1, that's 82. And then 10 squared plus 1 is 101. And they want me to find the sum, aka add all of these numbers together. Yes, Marsh is definitely going to be using a calculator. 26 plus 37 plus 50 plus 65 plus 82 plus 101 is the answer of 361. Literally, guys, I just added these on a calculator. That's what I was doing. Let's try another one. So sum of the series. Again, I am starting at a lower limit of 1, upper limit of 5. So I'm going to track this. 3, 1 minus 1 plus 5. Okay, 1 minus 1 is 0. 3 to 0 is 1. Plus 5 is 6. 3, 2 minus 1. Marsh can't write today. Plus 5. It's 3 to the first, which is 3. Plus 5 is 8. 3 to the 3 minus 1 plus 5. So that's 9. Plus 5 is 14. 3 to the 4 minus 1 plus 5 is 3 cubed is 27 plus 5 is 32. Got one more to go. Can I squeeze it in? I think I can. I got this. Okay, 3 to the 4th is 81 plus 5 is 86. I need to find the sum again because it's summation notation. So we're going to go 6 plus 8 plus 14 plus 32 plus 86 is 146 for an answer. Last example of the day. All right, so starting at 4, we're going up to 8. So I got 5 times 4 minus 2, 18. 5 times 5 minus 2, that's 23. 5 times 6 minus 2, that's 30, 28. 5 times 7 minus 2 is 32. And, right? Yeah, 30, yeah. And then 5 times 8 minus 2 is 40, 38? Question mark? It looks like it. Summation. Once more, we are summing up this information. So 28 plus 23 plus 28 plus 32 plus 38. My answer, 139. So the hardest part of series basics, or just dealing with series, is again sequences. That's the hardest part of working with a series. Otherwise, the actual series part, the whole summation notation and adding and finding a sum, that's not the hard part. It is finding the sequence, finding the rule that generates from the terms. That is the end of this video. I will see you later, savers.